Hello everyone, welcome to another video, and in this one we are talking about Agentic Workflows Design Pattern. So I'll probably host a series of videos moving forward in this AI engineering playlist where we will discuss about different design patterns which can be helpful for designing your agentic workflows. So the first pattern which we are looking forward to in this video is prompt chaining. So the agenda will basically talk about prompt chaining, what that design pattern is, how you can actually implement it, and then we're gonna build a sample workflow or an example workflow which will where we will implement the prompt chaining design pattern, and we'll build it from scratch. We'll see the code walkthrough and we'll actually run it as well live so that you all can see and understand how you can actually implement this design pattern from scratch. So let's start with the introduction first and let's see what we are going to understand. So it basically mentioned the workflows are a system where the large language models and tools are orchestrated through a predefined code path. So you can think of workflow as a series of steps which you can actually lay out and you have a full control on it. So if your agentic workflow is running, you are very well aware of what particular step is currently being run and then what is the next step. So you totally know that after a step A, the step B will be executed and then step C will be executed and then maybe the workflow will end and you will get the output, right? So the workflow, you can think of an agentic workflow as a collection of predefined code path which are orchestrated or basically linked together, right? And that is an actual definition of an agentic workflow. And in this video, we're gonna discuss about prompt chaining design pattern in that agentic workflow. So we'll see how you can implement prompt chaining design patterns in the agentic workflows. Now, before we go ahead, we should definitely take a look on what is prompt chaining. So as the definition mentions, prompt chaining decomposes a task into a sequence of steps where each large language model call processes the output of the previous one. So you can think of it as a chaining where you can think of multiple nodes are arranged in a chain and there is a serial control flow moving from one node to another. So what happens is that if there is two nodes and first node does some processing using the large language model, then the output of the first node is passed on as an input to the second node, and then the second node takes that as an input and then it tries to understand and then make a future LLM call depending upon the business case. So it can be any business case you want, and if your business case basically directs you to have a chaining workflow, then you can implement this prompt chaining design pattern in your agentic workflow, right? And you can add programmatic checks as well in intermediate steps. So what does that mean is that if at a particular point of time you want to halt and you want to check whether the performance of the large language model or the output of the large language model is accurate or up to the mark, then you can have a grader node or a gate, which can basically, why we are calling it as a gate, because it tries to answer whether the workflow should move forward or it should exit. So it is acting as a gate where it will decide whether I should allow the control flow to move forward or should I exit the workflow at that point of time. And in that gate, you put the logic of whether the output of the large language model is up to date or correct or not. If the output is correct, or if so far the large language model or your agentic workflow is working correctly, you can keep the control flow moving forward. Or otherwise, if you think that there is some hallucination or if it is not working correctly or if user has passed something which is not up to the mark, then you can fail the workflow, right? And that is what concept of gate is within the prompt chaining. Now this is prompt chaining, and moving forward we're gonna discuss an interesting workflow where we will implement this prompt chaining design pattern. We'll also implement a gate in our prompt chaining design pattern where we will actually see if we get an output from the large language model, that gate will have the capability to continue the workflow or to exit the workflow at will. Now let's quickly understand what we are building, or we decided to build a workflow which implements prompt chaining design pattern. Let's quickly understand what workflow we are building that will implement the prompt chaining design pattern. So the idea is this is a workflow which will gonna start and it will gonna build a model. In building a model, we're gonna create a GPT model here and we're gonna save it so that in the future nodes we don't have to create or define the model again. We can just utilize the same model which was built from the same configuration. So we're gonna keep the model with us during the entire graph execution. After that, we're gonna get the query topic. Now, when we get the query topic, this is a conditional edge, which is just like a checker, which we mentioned, or it is just like a gate, which will gonna decide whether to continue the workflow execution or should we stop. So getting the query topic, what it does is that whatever a user is asking to the large language model, it first checks that whether that query lies in the machine learning topic or not. If the query being asked by the user is a machine learning based question or lies within the machine learning domain, then this query returns a continue statement or a continue string which tells the graph that we can continue the workflow, and that moves to the answer query. So answer query node simply answers the query whatever the user is asking, and then the workflow ends. If the question is not based on a machine learning topic, or it is maybe some irrelevant out of the scope question, it will gonna directly exit the workflow. So the model will the future node, it will not be passed to the answer query node which actually answers your query, and it will gonna directly exit the graph abruptly. Now this is a gate, and this is a prompt chaining where you will see the response from one node is used as an input to the another node, and then again the response from the another node is used as an input to the third node, and after that it ends. So it is just it just looks like a chain, right? And the whole idea of making it a chain is because all of these nodes are dependent on the previous nodes, right? So that is why we have to make a chain. Every node's input is dependent on the output of the previous node which is executing, right? That's why we make a chain of it. So this is the workflow. We're gonna build it from scratch, and we'll use LangChain open source framework. We'll use LangGraph as well, and we have already built a lot of workflows on LangGraph in this AI Engineering 101 playlist. So if you don't have any idea about LangChain or LangGraph, I would suggest you to watch the previous videos. If you have some ideas, then we can go ahead, or you can like keep watching this, and we'll go ahead and we'll actually build the workflow from scratch. And I'll also suggest, even though if you haven't like watched, or if you haven't watched my previous videos, or if you haven't have any idea about LangGraph or LangChain, you can watch through this episode, and you can get an understanding of how you can actually build a workflow on LangGraph. So we'll be building this entire workflow on LangGraph. We're gonna arrange these nodes in a prompt chaining design pattern fashion. We're gonna introduce conditional edge, which will be responsible for implementing the gate, right? So let's move forward to the code part. So now we are in the code part, and I have again opened my AI Engineering 101 GitHub repo. So this is the actual repo which I have opened in my VS Code, and you can find it on GitHub as well. The link to the repo is always mentioned in the video description, as we used to have for the previous videos in this playlist. This is the agent here which I have built, and this implements the prompt chaining design pattern. So as usual, we're gonna first implement the open source libraries. So we'll first gonna import the open source libraries. So I'll gonna run this cell. This imports the open source libraries, right? After that, we're gonna define the shared state. So if you have watched my previous videos, you should have an understanding that if you are running a workflow, or if you are building a workflow in LangGraph, we have a concept of shared state where we keep all the information at one place that is passed from one node to another. So let's quickly define that. We also have a grader output. This is basically a structured output which instructs the grader node to return the response in this particular format. So it will gonna return a class, or basically a JSON object which will have a field from machine learning topic, which will be either true or false depending upon whether the query asked by the user is from a machine learning topic or not. After that, we have a build model node. Now this is the same node which we defined earlier, and let me hide that. Yeah, so we have a build node which I already, like we saw in the workflow image or the design. I'll gonna quickly run it. So this basically creates the OpenAI model where we are using GPT-4o Mini for this session, and this saves it in the shared state. So we don't need to create or call this method again and again every time we want to make a call to the LLM. We have saved the model in our shared state, and this shared state will be passed on to the nodes moving forward. So we can easily pick the model back from the shared state. After that, this is one of the important node where it checks whether the query which is being asked by the user lies under the machine learning topic or not, right? And this is gonna respond in the format which we want. So structured LLM grader has a structured output, which is the grader output. So this is the one which we defined above here. So this instructs the large language model to answer in this JSON format, where it will always have a from machine learning topic field, which can be true or false, right? Now this is how you let the model know that you have to respond in a structured format, right? After that, we also have a prompt, which is a very basic URL classifier that determines if a user's query is related to the machine learning topics. Given the user's query, return true if it is related to machine learning topic, otherwise return false. Fairly simple. After that, once you have built the prompt, you add the prompt or basically the query which the user is sending to the model here. And then once you have built the prompt, you can pass it through the structured LLM grader. And then after that, you can invoke this grader with the actual user query. Once you invoke this with the actual user query, it will give you the result. Now the result will be in the same JSON format, which is like very similar to the grader output class, right? So it will, like, the output is in the grader output class format. From the class, we have defined the from machine learning topic field in the class. We pick that field and we store that in the shared state. Now the shared state has a field from ML topic. Now this keeps the result of this LLM call, which can be either true or false depending upon whether your query is from a machine learning topic or not, right? Now we have saved this so we can utilize it in the future nodes, right? We saved that in the shared state. So I can quickly run this. After that, we have a small grader node, or we also called it a gate in the design. This is actually the gate which tells whether we should continue the workflow or we should exit. Now it totally depends upon the from ML topic field, right? Okay, so it depends upon the from ML topic field. Now this field has already been set here in the previous node, so I can simply check whether this value is true or false. If it is true, then I'll gonna continue, otherwise we're gonna exit. So this grader node will return the string depending upon what is the value from the ML topic. So if the query is based on the machine learning topic, we'll return continue, which will instruct the workflow to continue. Otherwise we'll return exit, which will instruct the workflow to exit. I can quickly run this. After that, we have a final answer query. Now this node is only called if we have a go ahead from the grader node, meaning if the query which is being asked by the user is based on a machine learning topic. So if it is the case, then there is a simple prompt: you are an expert in machine learning, answer the user's query under 200 words. We get the model from the shared state, we get the query from the shared state, and we build the prompt where we pass in the user query, and we are using string output parser, which simply instructs the model to output its result in a string format, nothing else. So we build the answer chain, we invoke the chain with the query, and we expect the model to answer. We store the result in the result variable. This will hold a simple string because we have already used a string output parser. So we don't need to do anything. We just directly get the string, directly get the answer as a string from the large language model. We stored this here, and then after that we save that in the shared state so that we can return back the result to the user. The point to remember is whenever you are building a workflow in LangGraph, you pass the input as the shared state, and you get the output back from the workflow after the entire execution in the form of the shared state. So it is very important, whatever answer you are trying to return or the result you are trying to return, you save that in the shared state, so that when the shared state is returned, your result is present there. So that's what we are doing here. We are putting the result in the shared state with the field AI answer. So AI answer will hold the result of the agent. Now I can quickly run this as well. After that, we have the method to which actually builds our graph. Now, building a graph in LangGraph is divided into two parts. First is adding the node or defining the node. Second is connecting those nodes with the edges. That is the first part we have done. Whatever nodes we have defined it. There are 3 nodes: build the model, get the query topic, and answer the query. Now you must be thinking that there was another node which is grader node, right? So that is not considered as a node. We will consider that as a conditional edge. So we don't need to define it in the node. We'll define it directly in the conditional edge because it returns a condition on the basis of which we can decide whether to continue the workflow or not. The first edge will be from the start point to the build model. After that, from build model to get the query topic. Once we have the query topic, we'll have to decide basically whether to continue the workflow or not. And this is decided by the grader node that is acting as a conditional edge here. So if the grader node returns continue, we move to the answer query node. If the grader node returns exit, we end the workflow. Now, if the query is under the machine learning topic, we get a continue statement from the grader node, and we're gonna move to the answer query node. After that, once the answer query node executes, we're gonna end the workflow. So your workflow can end in 2 ways. If the query is not based on ML topic, it will gonna end abruptly. Otherwise, the another node will gonna answer the query, and then it will gonna end with an answer. I can actually run it. Now we have all the methods defined. Now it is time to execute this workflow. So for this, I have another method defined, which is execute prompt chain workflow. Now what it does is that it simply calls the build graph, which was defined above. Now once we have the workflow compiled with us, we can execute that with a shared state. Now the initial shared state is the state which we're gonna pass into the workflow. So this has the user query. Rest of the things we don't have, because rest of the things will be put into the workflow as the workflow executes. So it will be put into the shared state as the workflow executes. And initially we have the query, and our query is what are the latest advancements in the machine learning. Now this query is obviously under machine learning topic, so our grader node should allow the workflow to run. And then after that, we pass this initial shared state to the workflow. We invoke the workflow this state with this shared state, and we get the response back. Now I mentioned that you get the response in the form of the shared state, so this will be nothing, this will be a shared state. After that, you can get the answer from here. So there are 2 things which we need to care about. First is the from ML topic. If the from ML topic is false, we will never get the AI answer. So if you will direct search for AI answer, it can be the case that you get a key error from Python. So it is important to check for the from ML topic first, and only if your query is from the ML topic or based on the ML topic, then only you print the AI answer. Otherwise, if the from ML topic is false, obviously this answer query will not be executed, and you will never have AI answer as a key in your shared state, right? And in that case, we're gonna simply say the query is not related to the machine learning topics. These are the few things we should always care about if we don't want our agentic workflow to stop abruptly, right? So I can definitely run this. So now this method is defined, I can execute it. So I am executing it with this query, and if I execute it, this will gonna happen. So determine if the query is related to machine learning topic. It was based on ML topic, so it moved to the answer node, so answering the user query. Now the model will take some time and will gonna present the answer. So this is the answer. As of October 2023, several notable advancements in machine learning have emerged, blah blah blah. So these are the answers it is trying to put in front of us. Now this is fair. The model was able to answer and you can change the model. You can make it, you can try it with GPT-4, you can try it with GPT-5 as well to see how the answers vary. Now the second thing, important thing is what happens if we pass on a query which is not based on the ML topic. Now that's where our gate should stop the workflow from executing. So for that, I'll gonna ask another query which I have saved here, and this query is obviously not related to the ML topic. This is, what is the capital of India? Now we don't want our agent to answer these irrelevant query because we have built our agentic workflow to only and only answer ML based questions, right? So if I have updated the method. If I execute it again, this time determine if the query is related to the machine learning topic. The query is not related to the machine learning topic. There is a reason, because the creator node returned exit. And why? Because when we asked the LLM model that whether the query was related to ML topic or not, it returned a false response. And you can actually see your shared state. So how you can see your shared state? Let me do one thing. So instead of doing all this, I will also print the agent response, which is nothing but a shared state. So once I redefine this, I'll gonna print the shared state here. Okay. Now, if I'll run this, I'll see the shared state. So the shared state looks like this, where we have a query, which is obviously what is the capital of India. We have the model, which has all the things here. And after that, if you will see here from ML topic, this is the field which was filled initially by the previous node, and it is false, meaning the question which the user or which we have asked from the model is not from the ML topic, and that is why it returned nothing, or it stopped the work, or the gate which we implemented stopped the workflow execution, and it returned the query is not related to the machine learning topics. And this is how you can implement a prompt chaining design pattern in your workflow. So this was it in the prompt chaining design pattern. I hope you understood this design pattern, and after this video you should be able to implement this design pattern from scratch. Now this was the first design pattern which we have discussed under the agentic workflows. I'll come up with more design pattern, more agentic workflows design pattern, which you can implement. And as we move forward in the next videos of the design patterns, we're gonna move towards more advanced design patterns, which you're gonna definitely see in the upcoming videos. Apart from this, this is the AI Engineering 101 playlist. You can check out the rest of the videos in this playlist. Most of them are really informative, where we are building some interesting workflows, or where we are talking about some concepts from scratch. So it should be very helpful. We also do the code walkthrough, and we try to explain everything from scratch. So that should also be very insightful. Apart from that, the link to this code walkthrough is added as a link in the description of the video, so you can go to the code and you can see it. You can fork the repo and you can actually run those workflow in your local machine and try to understand where things are going correct or wrong, all of them. And if you find this video helpful, do like this video, subscribe to this channel, share it with others, and I'll meet you in the next video.